All right. So, last couple days we've talked about quadratics specifically. But before that, in section 1, we talked about polynomials. And there was a part of a polynomial where it was wanting you to find the zeros. Okay? And remember, we had to factor it out to find all the zeros, right? Or you had to plug in numbers and guess and check. Well, if you have a fifth root or a fifth power or fifth degree polynomial, do you want to have to sit there and guess and check to try and find all the answers? Because that's going to take you forever. Especially if two of the answers are complex, well, then you can try every number under the sun and you're not going to figure it out because some of the answers are imaginary. So we need another method as to how to find zeros that's not simply just guess and check. Okay? And that's where remainder and factor theorems come into play. All right? So, to start with this, we need to review everyone's favorite part of math, which is long division. All right, so we're going to start just reviewing the concept of long division with just numbers. So,
81.
All right. So, let's say I wanted to divide this number by 4 without using a calculator. So, you're dividing 8,954 by 4. So we start and see how many times does 4 go into 8? Twice. 4 times 2 is 8. And then what do I do? So that's 0. Bring down the 9. 4 goes into 9 2 times. Remainder of 1. Bring down the 5. 3 times. That's 12. Bring down the 4. How many times does 4 go into 34? 8.
Remainder 2.
32. And you get a remainder of 2. Now, another way you could also write that. Instead of putting remainder 2. This is the way you did it when you first learned long division. But another way you can write that is 2 over 4. So you take the remainder and put it over what you're dividing by. And that, as I hear some of you say, is the same thing as saying a half. Or 0.5. Okay? So, that's basic long division. You've been doing that since 4th grade or 5th grade, depending on when you learned it. I know for sure 5th grade. Now, we're now going to carry that concept over, and now we're not just doing long division. Now we're going to do
Not all long division.
Now we're going to do polynomial long division. So, we're going to divide 2a squared plus 3a minus 8 by a minus 2.
You want to put that under
So, 2a squared plus 3a minus 8 goes there. A minus 2 goes on the outside. Okay? Now, this gets a little bit more complicated, but the reason we started with base long division is the same principles of base long division are true in polynomial. So you still start with the first number on the outside, which in this case, it's not a number, it's a variable, a. And you look, well, what's the first one on the inside? 2a squared. What do I need to take a times to get 2a squared?
2.
And
2.
a, 2a. So now, just like what we did with long division, you take how many times it goes in, and multiply it by everything on the outside. So I take 2a times a, that's 2a squared. But not only do I have to do the a, but I also have to do the 2. So I take 2a times negative 2, which is negative 4a. Now I want to pause a second to make sure we understand, one, where 2a came from.
Isn't the 2a line?
Do it again.
Okay.
I'm sorry.
No, you're fine.
No, you're good.
Blah,
So, how many times, so if we think about with numbers, if it was just 12 divided by 3, we think, okay, how many times does 3 go into 12? Well, 4. We just know that it happens 4 times. The same concept is true here. If it helps, think of it like this. That's really what you're doing. 2a squared divided by a. So I look, 2 divided by, well, there's an imaginary 1 there. Number divided by number. 2 divided by 1 is 2. And then I have a squared over a. So I have 2 a's on top, 1a on the bottom. What can I do with this 1a? Cancels 1a on top. So what do I have left? Just 1a. And that's where that 2a came from. Are you good with that?
Then you just drop that 2a squared down.
But he multiplied.
So now what I do is I take this and multiply by both terms here, just like you do with long division. So it's just like if I am taking 44 divided by 2, 2 goes into 4 2 times. But then what do? I take 2 times 2, which is 4, and I subtract, right? The top by the outside, and that's what I get underneath here. It's the same concept here.
Did you get that bottom A just from the first?
Yes, based off the outside here. So I'm looking at the first term and the first term. That was it. Yep. Are we good there so far?
I think so.
Okay. Now, what did I do here? Subtract. So what do you think you have to do here? Subtract. 2a squared minus 2a squared cancels. If that doesn't cancel, you did something wrong. You want those first terms to cancel. 3a minus negative 4a. 7a. Minus a negative becomes plus a positive. Yes, Peter. Are we good?
Yeah, we good.
Bring down 8. Now I do the same process all over again. What do I take a times to get 7a? 7 plus 7. Now I got to do the same thing. 7 times a is 7a. 7 times negative 2, negative 14. And again, subtract. What happens to the 7a's? And negative 8 minus negative 14 becomes a positive 6. So I have remainder 6. But just like how with long division, we don't want to write that as just R6. We do it the same way. It'd be plus 6 divided by whatever's on the outside. A minus 2. That would be my answer. 2a plus 7 plus 6 divided by a minus 2.
We might need to do another one of those.
We definitely will.
It gets always trying to find something.
Yes. Yes. Megan just asked a good question. I want to make sure everybody hears it. When you're doing long division, you always want to find something that multiplies by the first term that cancels the next number in line. So we wanted to cancel 2a squared. So then that went away. Well, then we had 7a. Well, now I want to cancel 7a. And then you keep going step by step by step until you cancel everything, until you get something like 6. Well, can a go into 6? No, so it's a remainder. How are we feeling here? We good?
Confused.
Another one.
Okay. We will definitely do another one, yes.
I'd love to be graded on simple long division.
Same.
Yeah.
All right. You are going to try this one. All right. X cubed minus x squared plus x plus 2. And you're dividing that by x plus 1.
You could say that'd be over though, right?
Yes, that'd be over, yes. So this is technically below this if you wanted to write it as a fraction, yes. So go ahead and try that. I'll give you a minute or two, see how far you can get, and then we'll go through it as a class.
Wait. What about the cube?
It's no different than the last one, it just has one more step. So instead of multiplying by a, you would have to multiply by x.
How do you get that in the first step? I can set it up. But after that,
Yeah, same. I can set it up too. Wait, what about the cube? Wouldn't it go with this and the other?
what?
Subtract this.
And then that's negative.
I got this. 3. You take x times to get x cubed 3 by 2. X squared, right?
All right. Seems like most of you got stuck. Oh, you're not done? All right. Okay, I'll give you another minute and a half, 2 minutes here.
Is it x squared minus 2x minus 2 remainder 4?
I'm gonna be honest, I don't know why I made this up.
All right.
Oh my god.
Did anyone get a remainder of negative 42?
Yeah, there's no more than that's my class. My class is so hard. I guess I tried really hard on this. Because I've actually
I thought I was doing okay, but I mean. I got a remainder of my 14. Roll.
Wow, what are we
You gotta be kidding.
Alright, here we go. Okay, let's start here. So, first step, look at the outside and the inside. So, I gotta figure out, what do I take x times to get x cubed?
It's one I thought was 4. That's
X squared. So, alright. Alright, so we've got another way of thinking about this is just take x cubed divided by x. Remember, what is division of exponents? You just subtract. 3 minus 1 is x squared. Now, I take x squared times x, which is x cubed. X squared times 1, which is 1x squared. Here's the tricky part. You have to now remember to subtract. X cubed minus x cubed, that cancels. Where you have to be careful is some of you then just canceled this as well. But it's negative x squared minus positive x squared. So that becomes negative 2x squared. One other thing is I looked around when you were doing long division. We didn't talk about this in the first example, and I probably should have. To continue to the next step, you have to have as many terms here as you do on the outside. So here I only have one term right now. On the outside I have how many? 2. So I got to bring one down. So I got to bring the plus x down before I can do anything else. Now that I have that, I just repeat that same process. What do I take x times to get negative 2x squared? Negative 2x. And again, how did I get that? Negative 2x squared divided by x. Negative 2 divided by 1 is negative 2. X squared divided by x is just x. Everybody with me so far?
Yep.
Now I take negative 2x times x. That's negative 2x squared. Negative 2x times 1. That's negative 2x. And again, subtract. Negative 2x squared minus negative 2x squared. That's gone. X minus negative 2x is 3x. 1 minus negative 2 becomes 1 plus 2, which is 3. But again,
It's not like the other.
I only have one term, so I got to bring another one down. So what do I take x times to get 3x? 3. 3 times x is 3x. 3 times 1 is 3. Subtract again. 2 minus, or 3x minus 3x gone. 2 minus 3 is negative 1. So my answer then,
I got super close.
I just had the wrong number at one point.
Yes.
x squared minus 2x plus 3 minus 1 over x plus 1.
Is there a
about that third step that I got.
I don't know why I have to.
Like the green 3x, that's where it all went downhill for me.
Okay. Please remember, I'm trying to record this for those of you that need to go back and watch it. And it picks up all the residual noise. So, okay. So, that's a review of polynomial long division. You did that last year in Algebra 2, hopefully. Okay, that shouldn't be anything new. What's the problem with this method? The amount of time it takes, right? It takes a while to write it all out. It takes up a lot of space. So I'm going to quickly show you a shortcut. Okay? We're actually going to do the exact same example we just did using what's called synthetic division.
No. Isn't this stuff like not always work?
Synthetic does not always work, but we'll talk about what cases it does and doesn't work tomorrow. For this example, it does work. So, the problem we were just doing was x cubed minus x squared plus x plus 2 divided by x plus 1. All right. So, to do synthetic, the only things you use are coefficients. The only things you use are coefficients. So, first thing we have to do is figure out, with synthetic, there's always a box. You have to figure out what is the root that goes in the box. So, you set the denominator equal to 0 and solve for x. So in this case, the number that goes in the box is -1. Okay? Then, you make sure your numerator is in standard form, which means it goes from highest power to lowest power. You also have to make sure every power is represented. So we look, what's the largest power we have? 3. What's the number out front of x cubed? 1. So I write that down. Then I go down. Okay, next power is 2. What's the number out front of that one? -1. How about 1? Because it's minus. The next one is also 1. And then, is there a constant? Yes. 2. The constant, we put a dotted line in front of, because this is what we call, or I call this, the remainder line. Whatever you get down here is going to be your remainder. That's going to tell you, does it go in evenly or does it not? Okay? We with me so far? Okay. Then, you draw an arrow down, and that first number automatically comes down. Automatically comes down. Here's what you do now. You take the number you just brought down, multiply it by the number in the box. So 1 times -1 is -1. And you put that right there underneath the second coefficient. The thing that's tricky about synthetic is you always add. It's not subtract like long division. It's the opposite. So I take -1 plus -1, which is -2. Then you do the same process again. Number you just brought down, -2, times the number in the box, -1, which gives us +2. And again, you add, which gives us 3. You take 3 times the number in the box, which is -3, and you add. You get a remainder of -1. So then I gotta look and see, okay, what was the largest, what was my degree of the numerator? 3. And I divided by x, so the largest power I should have left is 2. So now what you do, you start at the remainder line, draw a line. You know, this is your constant term. This is going to be your x to the first term. This is going to be your x squared term. So then I write out, okay, what's my answer? 1x squared minus 2x plus 3. The remainder, minus 1 over x plus 1. And if you look at that, that's the exact same answer we just got by doing long division, and this is extremely faster. Okay? So we will do some more with long division and synthetic tomorrow. Please try and have your homework done when you come in.